Hey everybody! It's been a long journey, but we're finally coming to the end of section P2 from the prerequisite chapter. So just really quickly, let's just run through what we've done so far. You started out learning about, or at least reviewing, the properties of exponents and what we can do with those. And we played with them for a little bit. We talked about the numbers that you should try to memorize so that when you do radicals, it makes the simplifying a little bit easier. We talked about what nth root was. When you take the nth radical of a number, what happens? What are you allowed to do? The nth root, if it's even, can we do it with negatives? No, we can't. Can we take an odd root of positives? You betcha. So then we went further and talked about the properties of radicals that were very similar to the properties of exponents. We played. We talked about how you can simplify radicals, all different types. Then we talked about how to combine them using addition and subtraction. And finally moving to division, where we had to rationalize. And even tricky ones where there was more than one term in the denominator. How we have to rationalize that using something new called the conjugate. All right, that was a 1-minute review of everything you've done so far. And we end with a weird thing called rational exponents. And you remember rational numbers from the beginning of the year. Rational, again, just means ratio or fraction. So we're going to see lots of exponents here that are fractions, but what does that mean? Well, for example, let's take our official definition here. I can rewrite a radical using fraction exponents. And here's what I'm going to do. I'm going to take what you see, the nth root of a. And look what I'm going to do. I'm going to rewrite it so you can see it a little bit better. The nth root of a, well, I'm just going to write it to the 1 power if that's okay. The reason why I'm doing that is notice what happens. I can rewrite that as a is the base, and now look where the numbers go. 1 over n. Did you see that? The number, the exponent that was on the base, is on the top of the fraction. And the number, that's the index, the type of radical, goes always in the denominator of the fraction power. So the nth root of a is the same thing as a to the 1 over n. And 1 over n is the exponent, and he's a fraction, so we call him the rational exponent of a. So, for example, we can also say the fourth root of a is a to the 1 over 4. And again, always turn your eyes to the denominator of the rational exponent because that always tells you what kind of radical or what kind of root you're playing with. Okay, but what if by chance we're going to put an exponent on the a? What's going to happen? Meaning, how about off here to the side? What if I have a to the 3 over 2? Okay, where did that come from? That comes from the fact that, well, first of all, remember the denominator is the type of radical. So I'll put that here, although we don't have to write the 2, right? It's a square root. But then now, look what's left over. You have a, and you have the third power. So in general, if you have something like the nth root of a to the m, you can rewrite it as a to the m over n. But no matter what, always put the type of radical, type of root, in the denominator. And the number on top can just be attached to the base. So a couple of just simplifications that we can do here, friends. Look at this. We have a to the m over n. Well, I can take the m, the numerator, out and see how I do this. That's legal. That works. I'm taking the denominator, the numerator, and just sort of factoring it out. That means the inside that you're left here, folks, this 1 over n, is by definition the nth root. And so I can write them like that, or I can write them with the m on the inside. All right, so just different ways of expressing, but these all mean the same thing. A to the m was the exponent on the a, divided by the type of radical is the n. All right, ready? Here we go. Now we get a chance to play. Let's change these, just playing them, from radical form with roots into exponent form. All right, number 1. Well, let's check and see. First of all, the type of radical is a square root, so that's going to be in the denominator, right? And then the power on the 3, the base, is just a 1. So I'm going to say, number 1, this should be 3 raised to the 1 divided by 2, where the 1, again, was what was on the 3, and the 2 is the type of radical. There you go. There's number 1. Look how easy that is. Isn't that cool? Okay, I think it's cool, so that's what's important. Here's number 2. All right, type of root, again, 2. That's going to be in my denominator. And we can call this the entire base because this is the whole thing being raised to a power. and the power is a 5. So how about we call this 3xy, let's keep them safe in parentheses, to the, okay, the denominator is going to be the type of radical, so it should be a 5 over 2. There you go. And finally, well, on number 3, the only radical here is just this friend, this fourth root. So let's ignore the 2x for just a second here, friends, and just play with the root here. This is the fourth root of x to the 3. So x is my base, the root is a 4, and the power on the x is a 3. Great. Now, we could actually go further because we can go back to exponents and talk about when we have the same base, what do we do with our powers, and we can add them. So this will actually be 2 to the x raised to the 1 plus 3/4. Common denominator, we get x, 2x to the 7 over 4. All right, so we use a couple little skills there at once. But just important, how do you switch from radical to exponential? That's cool. Let's go backwards then. How can I go from number 4, which is in exponential, back into radical form? Let's try. All right, remember, your eyes should always go to the denominators because that's the type of radical. So I know he's going to be some kind of square root. I can put the 2, or I don't have to because he's a square root. And the 3 should be attached to this base. All right, well, inside I should have x squared plus y squared, and the 3 goes there. There you go. You can always go backwards and double check. This is x squared plus y squared to the 3 divided by 2. How about number 5? All right, well, the 2 doesn't have anything on it. The exponents are only really on the y and the z. So let's see, let's ignore 2 for a second. 2 you can just sit by yourself. Now y, let's see. Look at the denominator. That's a fourth root. So that will be the fourth root of y, and the 3 on top gets attached to the y, times, let's see, my eyes again go to the power, that's the denominator, 4, so it's the fourth root. So again, times another fourth root of z to the, well, 1 power, but I don't have to write it, it's just z. Well, that's great, but again, remember, by properties of radicals, we can combine these into the same radical because they are, first of all, the same index, so it's okay. They don't have to be the same radicand, right? That's only if you're adding and subtracting. So really, my final answer would be 2 times the fourth root of y cubed times z to the first, or just z. There you go. It's kind of neat that at the end we can combine them. Number 6. All right, a to the negative 3/2. Ooh, negative. Maybe we should deal with that negative first. Let's see. The negative means, remember, by definition of negative exponents, he just goes downstairs and becomes a sort of a reciprocal to the positive 3/2. Okay, that's cool. So again, my eyes go to the denominator, and that's my type of radical. So I have 1 over, it's a square root of a raised to the 3rd. There we go. We could rationalize it, but for now, I just want you to practice knowing what the negative does in the power, what type of radical, and where the 3 goes. So I'm actually going to stop there for number 6. Good, folks. So now you can go back and forth. You can go from radical to exponential and vice versa. It's the simplifying that gets more fun. All right, here we go. Number 1, let's try to simplify this using the knowledge of rational exponents. Now, in general, you want to try to keep it in rational exponents if you can. Going back from rational into actual radicals, I wouldn't suggest. I think it's much easier and simpler to just play with the powers. All right, well, let's deal with this one. I want negative 32 to the negative 4 over 5. Okay, like before, there's so many different ways to solve these and simplify these, friends. I'm going to try to find the best way to help you remember. Do you remember in the previous page, we had this notation here that said I can take the numerator and sort of factor him out because the inside does turn into a radical. Watch what I'm going to do. I'm going to take the top number, and I'm actually going to grab the negative with it too. I'm going to factor that out. So he becomes negative 32. When I factor out the negative 4, he's going to come out here. When I do that, what's left on the inside is a 1 on top and the 5 on the bottom. All right, that makes sense because if I actually went back and tried to multiply these two powers, I would get negative 4 over 5. So this is legal. Why the heck am I doing this? Because what does this mean right here? What kind of radical are we taking of negative 32? And it is indeed the fifth root. Ah, okay. So now, what is the fifth root of negative 32? First of all, is it legal? It's a negative number. Is it okay? Oh, sure, because it's a fifth root. It's an odd root. So negatives are totally coolio. What did we multiply 5 times to get negative 32? And I think this is negative 2. So in your brain, you're thinking to yourself, what is the fifth root of negative 32? And it should be negative 2. So this quantity inside the parentheses becomes negative 2. What was still on the outside? The negative 4. Okay, so I brought out the negative 4 so I can turn the whole inside the parentheses into sort of a mental radical. I'm taking the what root? Oh, the fifth root of negative 32, which simplifies very nicely to just negative 2. Okay, we're not done though. Let's do negative 2 to the negative fourth power. Let's deal with that negative. Where is he going? He's going downstairs. So it becomes negative 2 to the positive fourth. Okay, well, that one's not too bad because it's the fourth power. What is negative 2 to the fourth power? Negative 2, negative 2, negative 2, negative 2. Me thinks it's a positive 16. So all that work, folks, goes to 1 over 16. All right, so take out, going back to the top here of number 1, take out the top numerator. Let the denominator determine the type of radical so you can simplify that first and then just bring back the numerator at the end to finish it off. Good job on number 1. Okay, let me walk you through number 2 a little bit. And again, feel free to pause and try it on your own to challenge yourself and then catch up with me afterwards to see if we match. All right, friends, number 2. Well, let's see what we got. There's no powers on the outside, so there's nothing I need to distribute in, so that's good. Well, maybe I can just literally try to multiply them and sort of multiply the alike terms here. I have 2 numbers, so negative 5 and 3 gives me a negative 15. That's pretty cool. But then I have an x to the 5/3 and an x to negative 3/4. I have same base. Remember, when you're multiplying same base, what do you do to your powers? Big addition, right? So it becomes negative 15 times x to the, well, let's add them. 5/3 plus a negative 3/4. All right, well, it looks like we have to find a little common denominator here. Ready? Can you do it? Let's make a common denominator. Let's see, we have 3 and a 4 on the bottom, so let's make it 12. How about that? So my first fraction, I'm going to make it 12 on the denom, which means I need to multiply top and bottom by 4, right? So how about 20 over 12? You know, this whole plus negative is just the same thing as minus, right? Okay, done. Now, common denom, if I'm going to use 12 on the other one, I'm going to multiply top and bottom by 3, right? So I'm going to change this one to 9 over 12. 20 over 12 minus 9 over 12. Awesome. Okay, final answer. We have the 5 and the 3 and the negative made negative 15 again. X to the 11 over 12. Not that we need to know, but this is the what kind of radical? The 12th root. So just pretty cool to know that this would be the 12th root of x to the 11th. Don't need to write that, and actually you can see it's much more compact when it's in terms of exponents. Radicals just look a little bit more complicated, I think. So final answer here looks great. All right, number 3. Can we simplify this one? Well, the problem is the exponent is smaller than the index, so I can't pull out any a's. Well, that stinks. But hey, can we just rewrite this in terms of rational exponents? Watch. This should be a to the, let's see, it's the 9th root goes in the denominator, and the 3 that was on the a goes on top. Oh, that's cool. Hey, 3 over 9, that totally simplifies to 1/3. Okay, we can leave it like that, or if you want to put it back in radical, that's just the 3rd root of a. Wow, that was really pretty. What a nice little simplification there. Math is sweet. Number 4. All right, look at that, a double radical. We learned before that if you have the double radical, you can multiply that, and that's totally fine if you want. So let me show you 2 different ways. This inside radical is a square root, right, because it's empty. So we could say by the properties of radicals, this is 125 but now it's inside of a 3 times 2, a sixth root. Okay, that's kind of cool. Let me see, what can I do with that? Because 125 is 5, see, times 5, that's 5 to the third, right? Inside of a sixth root. Just like number 3, I can't pull out any 5s because the exponent is smaller than the index. But again, can we rewrite it? Let's rewrite it using rational powers. How about 5 to the 3 over 6? Or 5 to the 1/2? Wow, that's really cool. We could leave it like that. Or that's the same thing as just root 5. That's crazy. Can you believe that? Do you know that this is actually the same thing as just the square root of 5? That's crazy, crazy. Okay, that's one way to do it. Well, let me show you another way. Let's go into rational exponents like right away. Here's what I mean. The inside is 125 to the, well, let's see, it's a 1 exponent and a 2 square root. So how about 1/2 power, right? And then on the outside, this whole thing is under a cube root. So that's a 1/3 power. Huh. Okay. So, hey, how about exponent raised to another exponent? Remember what we do with those two? We multiply them. Good for you. 1/2 times 1/3 is 1/6. And then I can change the 125 to 5 cubed. And can you see where I'm going? I'm basically back over there from where I was in the green. So either path is fine. Change it using radical properties like we did before, or rational exponents. Either one. All right, last two, and we're almost done. Good job. Number 5. Well, let's see, we're multiplying. We have 2x minus 1 to this power, and 2x minus 1 to this power. Oh, wait, so the bases are the same? Well, sweet. If the bases are the same, what can we do with our exponents? Yep, that's what I think. Okay, so why don't we just call this a big old 2x minus 1 to the, how about 4/3 power plus the other one, which is negative 1/3 power. Well, 4/3 plus negative 1/3, that's really 4/3 minus the third, right? So that's basically 3/3 or 1. Oh, wow. So this whole thing just turns into 2x minus 1 to the 1 power, or just that. Sweet. Last one, friends. Number 6. Okay, same idea with 5. Do you notice I have an x minus 1 on top and an x minus 1 on the bottom? Same base. Same base dividing. What can we do with our powers? We can subtract. But what's the power on top? I don't see anything on there. Oh, it's a 1, that's right. So how about we just change this now to x minus 1, the base, to the top power minus the bottom. Ooh, see how I'm subtracting a negative, minus a minus? Remember, a minus is the same thing as a plus. So it basically just turns into a power of 1 plus a half, or 3/2. So final answer, how about x minus 1 to the 3/2, and you can walk away. So that's how rational powers work. Once you get going, they all have the same properties of exponents as we learned before in terms of multiplying them, adding that kind of idea. But just neat how we can always have fractions in our exponents as well. And the important thing is the bottom number always tells you the type of root or type of radical that we have. Folks, you have reached the end of section P2. Congratulations and great work. See you next time.